when you hear my name. But that's not all I did. A book that I wrote is arguably the most important scientific book ever created. This book is called Philosophiae Naturalis Principia Mathematica, or just Principia. Probably the most known theory from this book is my theory of gravity. This occurred to me while I was watching apples fall. I thought, why do apples fall? Why don't they just hover there? I did a lot of testing experiments and found out that's because of an invisible force that attracts objects to different objects. I found out that every object has this force, just bigger objects have bigger forces. I learned that this is not only why apples fall, but why the moon orbits around the Earth, why the Earth orbits around the sun, and one for other stuff. My second most known theory is my theory of inertia. This means that if an object, such as this apple, is resting on a table, it will not move, unless a force, such as my hand, moves it. And also, if I took this apple to space, where there's no gravity or no friction, and chucked it, it would keep going in a straight line until a force such as an alien spaceship knocks it down. Now, if you've ever and now my 3 laws of motion. I made 3 laws of motion. The first one is called the Law of Inertia because what it does is describes what inertia is. And I already said what inertia is, so I don't need to explain that very much.
Well, you didn't say that that's inertia, you said.
Whatever.
And you didn't name Stop interrupting him.
Anyway,
he's important.
my second law, oh yeah, it's an equation. F divided by m equals a, or force divided by mass equals acceleration. This means that if you have an object, and you know its mass or weight, and you know how much force you applied to that object, you divide that amount of force by its weight, and you get the increase in speed of the object.
What?
It's useful. Anyway, my third law is the one that is most known exactly, I guess. Like most whatever. It says that for every action, there is an equal and opposite reaction. So if I push Drew, then a force equal to the force I did on Drew. So like if I push Drew, let's say I pushed him really hard, then a really hard force will be acted on me. It's just it doesn't affect me as much because I'm already going this way.
Kind of like shotguns.
Exactly. Anyway, if you ever wondered why things orbit, I discovered that too. When the moon, for example, was created, it was moving. Its inertia was keeping it in a straight line. But until it got near Earth, and Earth's gravitational pull pulled the moon toward Earth. The gravity and the inertia balance out, making the moon go on a circular orbit around the Earth. These are some of many theories from my revolutionary book, Principia. I'm done. Samara. January 4th, 1643.
Oh, wow. You just said it. Wow.